Case 4 is when our fx is in the form of exponential of fx times vx. And our vx is got to be the UC function. So the definition of the UC function is what? It's a function which is in the form of power x, right? And that the power x got to be the positive number. And it's got to be sine or cos, and it's got to be exponential. So that is the UC function. You've got to go back and take a look at this definition from our first method of what is the method? Comparing of the undetermined coefficient method. It said that if our fx is in this form, 1 over pd times exponential of ax bx. This is our fx, right? It's equal to exponential of fx times 1 over pd plus a times vx. This is the formula for this case. Let me prove it. So if we have the exponential of ax fx, this one is the first derivative of exponential of fx times exponential of ax times fx. So the first derivative of this function is equal to exponential of ax dfx, right? Plus fx times the exponential of fx. The differential of exponential of ax by dx is equal to the first derivative of exponential of ax by dx is equal to a times exponential of ax. We have this term and this term look the same for both terms, right? So we can take it out. But the thing is that this fx is at the back of your differential sign. So when you want to take it out, you've got to take it out to the back, right? But for the exponential term, it is in front of your derivative side. So when you take it out, you've got to put it at the front. So by that, you would get right? Just do the same for the second and third derivative, you would end up the same meaning. So now what if we have our differential equation in the form of so if for the second derivative you would get something like this. You do derivative of this one, you would get what? Right? Plus and then this term you got to do just exactly the same meanings of this one, right? This one is just exactly the same meanings of this one, right? So you would get a times, which is equal to so you can take exponential out and fx out, you would get is it right? It's the second derivative of this one, so you would get exponential, the second derivative of this one, and then plus the first derivative of this one. So you dip this one, you would get this term and this term. Oh, here, the a squared, right? Because you put a back there, you would get a squared there. Okay, now you would get if fx plus just getting confused with, yeah.